Hey everyone, we're going to take a look at problem 2-33 together. In problem 2-32, you figured out that having an equation for a parabola in graphing form allows you to know the vertex, the orientation, and the stretch factor. And that knowing these attributes allows you to graph without having to make a table. How can you make a graph without a table when the equation is given in standard form? So we're going to look at this equation here. It says, what is the orientation? That is, does it open upward or downward? How could you change the equation to make the graph open the opposite way? So the first thing we have to look at is the A value, and that is this number right here. Is it positive? Yes, that means it opens up. If we wanted to change the orientation or make it open down, we would have to make this a negative. So a -2 would make it open down. I also can tell the stretch factor from my A value. So my stretch factor is 2. So does this mean it will get bigger or stretch or get smaller and compress? It will stretch and get bigger. So part C is asking us to identify the vertex. Can we do this just by looking at the equation? So remember that our vertex comes from our H and our K. And again, we don't have that here when we are in standard form. So we are going to have to turn this into graphing form. To do that, we are going to have to factor. So I'm going to rewrite our equation here. So we are going to have to factor this. Basically find our x-intercepts to start. So the first thing I have to do is factor out our GCF, which is a 2. So I'm going to divide each of these by 2. So now I end up with 2 times x squared plus 2x minus 15, because I divided each of these by 2. Now I'm not done quite yet. I need to factor this part here into a binomial. So I am looking for factors that add to 2 and multiply to -15. We are factoring like you learned in Algebra 1. So factors of 15, I immediately think of 5 and 3. 5 and 3. But one of these has to be negative so that I can end up with a -15. And one has to be negative so that I can end up with a 2, because this right now would give me an 8. So because I want a positive 2, I'm going to make my 3 negative here. So my new equation is x plus 5 and x minus 3. So from here, I have an idea of what this graph would look like. So I'm going to put that here. If I would solve each of these by setting them equal to 0, I would have a positive 3 as one of my x-intercepts. So this is a 3, and a -5 as my other. Okay. Now this doesn't necessarily help me find the vertex yet. But if I draw in my axis of symmetry, so it would split this parabola in half. So I've got 8 here, so that's going to be right in the middle here. This is my axis of symmetry. I know my vertex has to lie somewhere on this line. And this line is going through -1. So that tells me that the x of my vertex has to be -1. And to find the y, I can just plug that into my equation here. So 2 times -1 squared plus 4 times -1 minus 30 will give me my y value of my vertex. So right now I have a -1, and I need to find what the k value is. So -1 squared would give me a +1. 2 times +1 is 2. 4 times -1 would give me a -4 minus 30. So 2 minus 4 gives me -2, minus another 30 gives me a -32. So I have -32 here. So this is my vertex. So that would be way, way down here. And then I would have a parabola that kind of looks like this. And that makes sense because we said it should open down. Now to write this into graphing form, we would have to take our vertex and our a value and plug that into our equation here. Okay, so I have y equals, my a value is 2 times h minus k. So my h value is a -1. So minus a negative turns this to a +1 minus 32. And this is my graphing form. You're going to be doing a little bit of this on the next problem here, but hang with me. I know this is a lot. This is actually all things that you have done in Algebra 1. We're just kind of turning up the dial a lot and making it a little more difficult because we think you can handle it. All right, so stick with me. We're going to keep practicing this and we'll be good to go.